So these AI models can now read your mind?
Artificial intelligence is improving and mimicking how the brain translates what we see into mental images as neuroscientists try to figure it out. A recent study by Japanese scientists to be presented at the Computer Vision Conference shows that AI can read brain scans and recreate realistic visuals. The new study is the first to use a German AI algorithm called Stable Diffusion, announced in 2022. After training on billions of text description images, Stable Diffusion and other text-to-image generative AIs such as DALL-E 2 and Midjourney create new images from word prompts. Through photo captions, Stable Diffusion was able to read brain scans with less training per person than earlier AI algorithms that needed massive data sets. The AI algorithm uses data from occipital and temporal lobes, which are important in image perception. Functional magnetic resonance imaging brain scans detect blood flow changes to active brain areas which the system processed. People look at photos and their temporal lobes mostly register information regarding the image's contents such as people, objects, or scenery, while their occipital lobes mostly register layout and the perspective such as scale and position of the objects. The new study added training to the Stable Diffusion algorithm using brain scans from 4 volunteers as they examined 10,000 photos from the University of Minnesota's online dataset. Some brain scans from the same 4 subjects were used to test the AI system after training. Each AI-generated image begins as noise, similar to TV static, and is replaced with discernible elements as the Stable Diffusion algorithm compares a person's brain activity patterns while viewing a photo to patterns in its training dataset. The technology generates an image that accurately represents the information, layout, and viewpoint of the photo being viewed. The new approach has been more efficient than earlier models, required less fine-tuning, and could be trained with a smaller dataset. The researchers discovered that brain activity, particularly in the occipital lobe, gave sufficient information to recreate the layout and perspective of the photographs being viewed. However, the algorithm struggled to produce some detailed items from the original photograph and instead produced abstract figures. One solution to this difficulty would be to utilize larger training datasets that would allow the system to anticipate more features, but the fMRI set was too small for the current study. Previous methods for reimagining what our brain sees were to assume that an image was made up of pixels or simple forms. However, it is known that the human brain processes visual information hierarchically, extracting multiple levels, elements, or components of varying complexity. Yet, Japanese scientists have been at the forefront of experimenting with this new approach since 2018, when 4 scientists from Kyoto University used neural networks as a proxy for hierarchical organization of the human brain and to recognize objects rather than binary pixels. In their study, 3 subjects were presented natural visuals such as bird or person photos, artificial geometric forms, and alphabetical letters for varied amounts of time over 10 months. Some subjects' brain activity was tested while viewing one of 25 images. Other times it was logged after individuals were asked to recall the visual. After scanning brain activity, a computer decoded it to visualize a subject's thoughts. Visualization technology would allow you to draw pictures or make art simply by imagining something. Your dreams could be visualized by a computer. Psychiatric patients' hallucinations could be visualized, assisting in their treatment. And brain-machine interfaces may be one day allow communication with imagery or thoughts. While the thought of computers reading your brain sounds wonderful, Japanese researchers are not alone in their futuristic efforts. For example, former Google Xer Mary Lou Jepsen is developing a hat that will enable telepathy within a decade, while entrepreneur Brian Johnson is developing computer chips to implant in the brain to boost neurological functioning. So what are your thoughts on this? How many years are left to become cyborg humans or go lost in an Inception reality?